Fuzzy image. Think of a fuzzy image as a translation error between what the computer is trying to say and what the display is physically capable of showing. While a completely black screen is an obvious hardware failure, a fuzzy, blurry, or stretched image usually points to a configuration mismatch or a mechanical misalignment. For the CompTIA A+ exam, you must understand that diagnosing a fuzzy image requires you to ask one immediate question. Are we looking at a projector, or are we looking at an LCD monitor? The troubleshooting steps for each are completely different. Part 1. Projectors: the mechanical focus. If a user complains that a presentation on a projector is fuzzy, the issue is almost always mechanical or optical, not digital. The focus ring. Projectors use physical glass lenses to throw light across a room. Just like a pair of binoculars, that lens must be adjusted based on the exact distance to the screen. If the projector was bumped or moved, the image will fall out of focus. The fix. Have the user physically turn the grooved focus ring on the lens barrel until the text becomes razor sharp. The keystone effect. If the projector is not perfectly centered and level with the screen, the image will look like a trapezoid instead of a rectangle. To fix this, users apply keystone correction, which digitally shrinks one side of the image to make it square again. The trade-off: extreme digital keystone correction forces the projector to compress pixels, which makes the text look incredibly fuzzy and jagged. If the image is blurry, zero out the digital keystone settings and try to physically level the projector instead. Part 2. LCD monitors: the native resolution. If a user complains that their brand new flat-screen desktop monitor looks blurry or soft, the hardware is perfectly fine. You are dealing with a resolution mismatch. Unlike old CRT tube monitors, an LCD panel has a fixed, physical grid of microscopic squares called pixels. This is its native resolution, for example, 1920 x 1080. The problem: if the operating system is outputting a signal that perfectly matches that grid, 1080p, the image is perfectly mapped, one digital pixel to one physical square. It is crisp. Interpolation: the fuzziness. If the user goes into Windows and lowers the resolution to 1366 x 768 to make the icons look bigger, the monitor still has 1920 x 1080 physical squares. It has to stretch that smaller signal across the larger physical grid. To do this, the monitor uses a mathematical algorithm to guess what color the extra pixels should be. This process, called interpolation, inherently blurs the edges of text and images. The fix: always right. Click the Windows desktop, go to Display Settings, and ensure the resolution is set to the exact option marked Recommended. This is the OS confirming it has read the monitor's native resolution. Part 3. Operating system scaling. Sometimes, the native resolution is set perfectly, but a specific application still looks like a blurry mess. This is a software issue caused by display scaling. Modern 4K monitors pack so many microscopic pixels into a small space that if Windows displayed everything at a true 1:1 ratio, the text would be too small for a human to read. The OS solution: Windows uses scaling, usually set to 150% or 200% on 4K laptops, to artificially inflate the size of text and menus so they are readable. The legacy conflict: modern apps handle scaling beautifully. However, older, legacy business applications do not understand how to scale. When Windows forces them to inflate by 150%, they stretch like a low-quality JPEG, becoming incredibly fuzzy. The fix: you can write. Click the legacy application's executable file, go to Properties Compatibility, and check the box to override high DPI scaling behavior. This forces Windows to leave that specific program alone, restoring its sharpness. Part 4. The analog legacy: VGA ghosting. If you are dealing with older hardware using a blue VGA cable, fuzziness can be an electrical issue. Because VGA is an analog signal, it is susceptible to degradation. If the cable is too long, is missing a grounding pin, or is running too close to heavy power cables, the electromagnetic interference will distort the waveform. The symptom, this often manifests as ghosting, a faint, blurry shadow trailing slightly to the right of dark text on a light background. The fix: ensure the VGA cable is tightly screwed into the ports on both ends, route it away from power bricks, or ideally, upgrade the connection to a digital standard like DVI, HDMI, or DisplayPort, which are immune to analog ghosting. Summary for the professional technician. To lock this in for your exam troubleshooting steps. Projectors. A fuzzy image requires adjusting the physical focus ring on the lens or reducing aggressive keystone correction. LCD monitors. Fuzziness is almost always caused by running the screen below its native resolution, forcing the monitor to blur the image via interpolation. Software. If only one older program is fuzzy, it is a conflict with Windows Display Scaling, DPI settings. Analog cables. If using VGA, a blurry shadow means you are experiencing signal degradation or ghosting.